and welcome to this lecture. So in the previous lecture we covered this important function, and that was check Mario X collision and converting the mushroom into fire flowers and vice versa, and we also adjust the Mario for the X collision. So similar to that of X collision, we also have the Y collision, and Y collision can be with ground, with the enemy, with the bricks, and we have something that is a power up. So there can be mushroom, and you can also have the fire flowers. So let's make that collider again, that is defining this check Mario, and it should be Y collision now because we have already covered the X collisions. So just keep here a current object as an argument here. So basically this check Mario Y collision basically checks for the collision when Mario moves along the Y axis. So for that we have to just set up a collider first, and let me say ground step, should be ground step or pipe. So there can be collision with the ground step or a pipe, so it should be step or pipe. And let me just initialize it from the Pygame module, and we have sprite, and that should be sprite collide any, and just call here that is the current sprite would be the Mario, because we are just checking if the Mario collide with the group, and here the group will be ground step, and you can see pipe group. So it is basically a boolean type. It will return either a true or a false based on the collision. So next can be enemy, so there can be the enemy collision, and let me just define by the same procedure. And here the first thing to collide would be Mario, that is our main character, and the group here will be enemy group. So let me say it's this enemy group, and next collision can be with the brick. So let me just make a brick here, and it should be this Pygame module, and just call this sprite collide many, and obviously our main character is in Mario, and the collision here can be with our brick, that is brick group. So let me say brick group here. So next collision can be with the coin. So let me define another, that is a collider here, that is coin collider, and let me say sprite collide any here, and our main character, and in this case we have Mario, and our group will be coin group, that is coin group. So we have also covered this coin box. Now it's time for power up. So let me say it power up, and power up is basically something that is star, mushroom, and fire flowers. So that collision should be also unavoided. So let me say Mario here, and collision can be here with the power up group. So let me just put here power up group. So this will be our main collision. So in the Y axis we'll just now implement in order to work with this collision. So one more collision I want to make sure here is about this, that is, let me say I have to just prevent here a collision conflict. That is, what if we have coin and bricks? So what if we have coin and bricks that is near this Mario at the same distance maybe, and what basically which should be given the more priority to collide with? So because we have this coin embedded in this brick, so inside the bricks we'll have this coin, and if there is a collision, which should be given a more priority? So that is to check with this not PG sprite. We won't be dealing with the collision, rather we'll just make another function to handle it, and we'll say prevent collision conflict. So it would be prevent collision conflict, because we have to now prevent this collision when there is two collision based on the priority. So if there is a coin box and bricks that is basically colliding at the same time with our Mario, then one collision should be avoided. So this will be implemented by this prevent collision conflict method. So just pass here brick and our coin box. So after that we're gonna just check for this collision. So first let's start with the coin box. So if there's a collision with the coin box, what are you gonna do? We'll just call this function that is adjust Mario, and instead of this x collision, we'll just pass here y collision, and this is the function to be implemented. And here what you're gonna pass is our coin box, that is a collider. And similarly we'll just check for our brick, that is, let me just put here elif, and if it is a maybe brick, so what if there is a collision between the brick and our Mario? So this should be also handled by this same method. So let me just put it here, and instead of a coin box, now it should pass a collider as a brick. So next thing what you're gonna check is, we'll just check for this ground step or pipe. So I'll say that is elif this ground step pipe. Just let me copy it and let me paste it here. And if it is true, basically if there is a collision between ground step or pipe with our Mario, then what are you gonna do? So in this case we have to now again, that is, implement another function. Maybe we'll just create as adjust Mario for let me say adjust Mario for y ground pipe collision. So let me say y ground and pipe collisions, and just pass here our collision, that in this case is obviously ground step or pipe. So now we have now to implement this all method again. So next thing what you can have is enemy collision. So we'll have the enemy collision now, and let me just put here elif enemy. If there is a collision with the enemy and our Mario in the y-axis, what are you gonna do? We'll just check for if our enemy is, if our Mario, not enemy, if our Mario is invincible. That means if our Mario did not die basically. So that means let's check this invincible parameter here, and if our Mario is invincible, what we're gonna do here is we'll just make our enemy to kill. That is, just remove the enemy from our gameplay because our Mario is invincible basically. So next thing what we're gonna do is we'll just add this, that is enemy now, to our sprite about to die here. That is a list basically. So sprite about to die group, and just add it there our enemy, because our enemy is about to die. And next thing what you're gonna do is we'll just call this something that is start death jump here. So let me just search it. So it should be something that is, it should call from enemy. So this is the enemy function. So from enemy what you're gonna call here is start and death jump. So it should be start death jump function, and in this start death jump what you're gonna pass is c dot right. So movement here should be right, and our enemy has been removed from our gameplay because there was a collision in the y between the Mario and our enemy, and when Mario did not die basically it is invincible. Then what you're gonna say, enemy has to be killed. So next thing what you're gonna do is else part, that is if our Mario is not invincible. So what you're gonna do here, so we'll say I'll just call again for this adjust Mario for y collision, but in this case let me just make another function to handle this, and it should be adjust Mario, that is not enemy, it is adjust Mario for, instead of x we have y and enemy, and I'll say enemy collision, and just pass here enemy, just pass here enemy. And now what you're gonna do next is we have to check for power up. So remaining is for the power up. So let's check here elif power up. So what if there is a collision between the mushroom or a fire flower with our Mario? So what you're gonna do, first we'll check if the power up is, that means if our power up dot name, so get the name from the power up, and if it is star, if our power up is star, what you're gonna do is obviously I'll kill that power up first, and let me just remove this power up now, And next thing what we're gonna do is we'll set this Mario invincible, that is Mario, and just call here invincible should be true, because now it has just acquired this star, so Mario should be invincible now. So next thing what we're gonna do now would be this invincible time should be now current time, so don't forget to add it as this Mario invincible. We should have something that is invincible start timer. So here is a start timer, and it should be now current timer, because this current time is basically our invincible start timer. So next thing would be outside this basically our if condition, what you're gonna say is test if Mario is fallen. So that means we'll say what if our Mario is falling, or what if our Mario is to be died. So that should be implemented in here. Test if Mario is falling, let me say is falling here. This is the function to implement again. Now let's first go with this prevent collision conflict. Let's implement that first. So this prevent collision conflict is basically a method in order to check for the two collision, that in this case here is obstacles are brick and a coin box for our Mario. So in these two obstacles we'll just set a priority, and if someone priority is higher, then we'll just remove the another priority or another having the lower priority from our gameplay. So let's do that. So this prevent collision conflict allows collision only for the item closest to the Mario center X. So that would be our implementation here. So which should have the higher priority means the obstacles that is close to our item, that is close to our Mario basically, will have the higher priority. So let's define it. So let me just first copy this name from here, and let me just paste it out here, and just give here self is the current parameter, and second will be obstacle, that is in this case a brick, and let me say obstacle 2 now, obstacle 1 and obstacle 2. So we'll check if obstacle 1 and obstacle 2, basically if there is a both the collision. So there should be the both the collision. That means if you see here, this was a brick and coin box, and there was obviously brick means Mario collision with the brick, and coin box means Mario collision with the coin group. So obviously there should be the obstacles, there should be the collision between them, and if there is a collision, then we'll just say just calculate me obstacle 1 distance. So how do you calculate this distance? Is from this Mario center X. So we won't be just extracting this Mario left and right, rather we'll just stick with the center X. So get me the Mario center X. So in order to get that top, down, bottom, left and right or center X, we have to first assess this rect and then center X. So next thing is getting this obstacle. So this should be obstacle 1, and we just have to just assess this center X from this rect again, and this will be our obstacle 1 distance. So next thing what you're gonna say is we'll just check for this obstacle here. So if the obstacle 1 and that is distance here is less than O, that means it is really closer. So what you're gonna do, we'll say obstacle 1 distance, in this case obstacle 1 distance should be multiplied by -1. So this will be the case. So when this obstacle should be basically changing its distance exactly by the opposite that it was basically in the previous case. So where it was aligned in the previous case, it has to be directly opposite to that of the previous. So similarly to that of this collision that we just created here with the distance, so let me just copy it, and we have now second collision that in this case should be obstacle 2 distance. So this obstacle to distance should be calculated same that of previously we created for this obstacle 1 distance. And we'll also check for this if the obstacle 2 distance is maybe less than 0, that means it is basically striking basically with our center x Mario position. Then what are you gonna do? We'll just make this priority higher. That means this obstacle to distance should be again multiplied by -1. So this should not be obstacle 1, it should be obstacle 1 distance. So next thing what you're gonna do is, now it's time to check for the weight of these obstacles. So in order to check that, we'll say if the obstacle 1 distance is lesser than this obstacle 2 distance, then what are you gonna do? So obstacle 2 should be now false, because we have a higher priority for this obstacle 1. So obstacle 1 is to be performed, that means collision here with the brick. So when you call this was obstacle 1, so collision with the brick should be performed rather than the coin. So similarly, what if we don't have this obstacle 1 distance lesser than that of obstacle 2 distance? So that will be implemented here, and in this case what we're gonna do is we'll just set this obstacle 1 again false. So now the collision should be with our coin and our Mario. So just now we have to return this obstacle 1 and 2. I'll say obstacle 1 and obstacle 2. Just return me that, and you get here that is when you call here. So we have now in the brick and coin box, that is obstacle 1 and obstacle 2. So next thing which was to be implemented is our, let me say, we have to now just go here, and so let's just start with this adjust Mario for Y ground pipe collision. So let's copy that and just paste it out here, and what you're gonna have here is self, and if you passed here, that was basically our ground step or pipe. So this ground step pipe was basically a collider object, so I'll say here collider. So what are you gonna do here? So next thing, this is basically for the Mario collision with the pipe on the y-axis. So for that we'll just check if the collider here, and just get me this rect bottom. This is the bottom axis or bottom component, and if it is basically greater than that of Mario rect and bottom, so this is referring to the weight. Basically if our collider is basically of high weight, so collider has the basically at the bottom is higher than that of our Mario bottom, we'll just set this Mario velocity to be, should be y velocity here, because we are just dealing with the y-axis, so it should be static. So there should not be any movement in Mario if our basically collider, that is collider, is bigger, or weight of a collider is bigger at this bottom component. So next thing what you're gonna do is we'll just now assign this Mario rect bottom as, it should be Mario rect bottom. Now it should be in our collider rect top, should be our Mario rect top. And next thing what you're gonna do is we'll check for the state of the Mario. So this is important, so we'll check if the Mario state, basically what is our Mario state. So if our Mario state is now, that is end of the level fall, let me say end of the level fall, then we'll say now the Mario state should be, the Mario state should be C dot walking to castle. So it is basically end of our game. So the next thing what you're gonna check is what if our basically this it is not end of level. So what is it is not end of level, so now state of the Mario should be walking state, because the velocity has been O, that means there should not be any run movement, and if there should not be any running state for our Mario, that should be now walking state. So just take here as a walk. So next thing, what if we don't have basically this rect bottom of our collider greater than that of Mario? That should be implemented in this else part. If our rect, that is collider rect top, that in this case rect top, is less than that of our Mario rect, that is we have to just set here first the Mario, and get this rect and top. So what if this top, so if you visualize, this is really important because now it's time to make our basically Mario to make fall. So now Mario state should be fall if basically this collider top. So in this collider we have something that is ground pipe. So if you have a ground pipe, and you should only fall because in this rect top is less than that of Mario rect top. So I'll just first set the velocity. So this velocity, that is y velocity, because we are just dealing with the y axis here. So this y velocity should be okay. So in the previous lectures we have this set basically our x velocity to something, maybe let me quickly check here. It was enemy y velocity to be 7. So we have to deal with that, and we'll just put here 7. So now Mario y velocity should be 7. And now what we're gonna do is we'll just set now after this that is rect bottom, that is to be here, let me say it should be now top. Let me get the top of our Mario rect, and what you're gonna do here, we have to now pass that is rect dot bottom here, so bottom component. And now what will be the state of the Mario? So I have already said you, in this case we have to have this fall state. That means Mario will be now in the falling state. So let me say state should be now c dot fall. So it should be falling state. So we have completed our adjust Mario for y ground collision. Now let's check first basically if our Mario is, so let me say here in this coin box and brick we have something that is adjust Mario for y collision, but it can't be handled in the same functions because basically coins are to be handled basically with checking the rect of our coin and Mario. And to handle this brick we have to do the same, but in the case of a brick we have to check for the brick, not for the coin. So let me make a two different function to do that, so it would be easy rather into just going for the same function. We'll just make it a two function here. So after this y, just make here coin box. So this is specified, this is for the coin box. And if you go here in the y, and if you just write here a brick, then it specifies that we are dealing with a brick. So now it's time to implement this adjust Mario for y coin, basically y coin box collision. Let's go deep down here and let me just paste it out. And in this case the self is the current object and the collider here is a coin box. So we have collider here is a coin box that is basically colliding with our Mario. So this function will just check if the Mario collisions with the box axis on the y axis. So let's define here is in first, let me check any statement, that is if our Mario, and just get me y, because we are just dealing with this y collision, so we have to get this y, and in order to get this y, x, y, left, right, top, down, we have to make use of this rect. So just get that rect and the y component, it is greater than coin, and it should be coin box rect. We have here rect and y. That means the weight basically for our Mario is greater than that of the box. Then what are you gonna do here? We'll check first for the box state, that is coin box state. So if it is in rest position, so mostly we'll have this coin box as in rest position. So I'll say if our coin box is resting, what you're gonna do, and I have to also check for the content of a coin box, because if it contains coin or not, so we should be sure that if it contains coin or not. So first we should check for the coin box and give this content here, that is just contents. And if this coin box contains, so basically this coin box is a group and we are just checking for its content. If it is coin, so if it's contain coin, let me just check here say.coin, and what you're gonna do here, so if it contains coin, then we have to just increase our ISO. So in order to reference that ISO, we have to go from the game info dictionary and give here c.score, and let me say just add, when you just get that coin, just add 200 point. And next thing what you're gonna do is we'll just start that is coin box and start a bump here. So this coin bump should be start bumping. So let me say start bump, and what you're gonna pass here is our moving score list. So it should be moving score list. So next thing, if the box contents is basically our coin again, and what you're gonna do here, again we'll just check if this again the box content, let me check it twice here, if the box contents again is again c.coin, then what you're gonna do here is we'll just make this game info again. So it should be c dot, to just reference this score we have to this coin total now. So now this coin total should be added with 1. So score should be 200 and the coin total should be added with 1, because we have just get that coin, and score will be 200, but the coin when you just reference to that coin text, this coin should be, or number should be added with 1 now. So next thing is we want to check here if it is not coin. So what you're gonna do, if the content is not coin, we'll just start bumping. So for that we'll just call this coin box and I'll say just start bump method here, and we'll just pass our moving score list here. So this will be our adjust Mario for Y box collision, and it is really important and easy to deal with, because if we just have this weight, basically if this Mario just collide with the coin box of the weight, or basically priority is higher for the Mario, then we'll just check for if the coin box stage is in resting position, which is basically this statement is basically always true. If this Mario rect is greater than Y, that means we'll just eat that coin, and if the content is obviously coin, we'll just add this score, that is 200, and if the coin is again that is content is coin, then just the coin total should be added with 1. And else if it is hasn't, the content hasn't the coin, then what you can do is we'll just start bumping here. And next thing, that is our next method, should be here adjust Mario for Y brick collision. So let me see, type bool, so it should be here we have passed coin box, and now it's time to implement the next method, and let me do it in the next lecture. So see you in the next.